So after submitting the abstract for this presentation, I changed the name because it is a bit of a misadventure in some of these cases. Now, unfortunately, in our environment, I do not have access to Splunk. We do have it in our environment, but getting anyone to say yes to piping our Jamf data into that is a little bit like pulling teeth. A little bit about me. I am one of 3 Mac platform engineers at NAB, and I've been there for 4 years. I've lost count of how long I've been a Mac engineer. It's coming up to around 15 years at this point. And I'm really keen on automation to the point that I actually started the HiveMind Automation YouTube channel where I make gadget reviews and how-to videos about different home automation concepts. And I was also featured on the Macadmins podcast home automation episode. I really kind of love tinkering with things and solving different problems with technology. Our NAB environment, we got about 4,500 Macs enrolled, which equates to around about 12% of our entire user base at NAB. And as I mentioned before, there's 3 engineers managing that 4,500 device fleet. And we just last week ticked over 46% of our fleet being Apple Silicon. And we'll see a little bit later how I equate that. Before we get into the nitty-gritty, a quick disclaimer. While this presentation does contain descriptions and resultant artifacts of code that I've written in the course of executing my role, the opinions expressed within this presentation are my own, and they should not be interpreted as those of my employer or as financial advice, not that I give any. Where required, and it's been necessary, I have obfuscated or removed sensitive data to comply with data classification rules and privacy guidelines, and to protect the identities of the guilty NAB staff appearing in the reporting artifacts. And for those same reasons, I can't really run live demos. I kind of don't want to, because live demos are fraught with danger. So a little bit about what we're going to cover is really my most recent misadventures in gathering and reporting on data that I pull from Jamf. We'll start with how it started, and you might see some similarities between what Martin was presenting and what I'm showing there. We'll also talk about OS patch compliance state. Hardware performance, which is not super relevant to the Jamf aspect, but definitely interesting and produced some really cool learnings as well. Device and lifecycle refresh eligibility, and a bit more about why when we get there. The installed applications and restricted software violations, which is the very definition of weaponizing this data. Now, everything that we're looking at today was produced by writing Python code, and possibly the most important Python library for this is pandas. If anyone's not familiar with pandas, at a really basic level, you take 2-dimensional arrays, also known as tables or spreadsheets, and you can do all sorts of data analysis on there. I'm also using the Plotly library to make some nice pretty charts and graphs, and you'll see why that is quite good a bit later. And there's an extra component called Kaleido for the Plotly library, which allows us to save those graphs that we generate into a PNG file programmatically. And that becomes important a bit later on as well. We're using the standard requests library to query the Jamf API. I would like to use AIO HTTP, but I haven't wrapped my head around that one yet. I'm also using some Selenium browser automation, and again, we'll see why a little bit later on. And lastly, using the Python to PPTX library to prepare a stakeholder report with all of the PNGs that I'm capturing. I can hear that GIF somehow. So why do we need to do this? Well, as was mentioned at the start of Martin's presentation, we want to be making data-driven decisions about our fleet and what we're doing. And by automating the generation of these reports, reporting is time consuming. I like automation. So pulling this information out of Jamf manually was taking me a ridiculous amount of time, and people were asking for this data. So building something that made it look pretty and was repeatable and very easy to run was quite important. As I mentioned before, with 1,500 Macs per engineer, and we're managing software packaging and patching, OS patching, support escalations, platform documentation, project work, and many other parts of the entire Mac platform, it's become really necessary to be as efficient as we can with everything that we're working on. And the other reason that I started this is at the start of last year, I did a 100 days of code Python edition code challenge. And part of that, it's optional if you guys want to follow my journey, but part of that was really about the pandas data analysis and the Plotly diagram generation. And I really wanted to kind of put what I'd learned into practice as I was going through that 100 days of code to build out some reports that were going to make better decisions about our fleet. And that really kind of started with being really kind of frustrated with something that looks awfully similar to this that I stole from Jamf's website. These policy statuses and also patch management statuses, they don't really tell you a whole lot about the actual state of your fleet without going and digging in more. And part of what this was also really only being able to see the state of our fleet at this point in time. So again, back to what Martin was saying, being able to look back in time was something that really made me want to do some stuff here. I wrote some Python to pull the number of machines in different smart groups for each major OS and dump it into a JSON file, which looks a little bit like this. Sleep for 5 minutes and then do it all again, and then just ad nauseum and keep doing that. And then I took those data, that JSON file, and using the Plotly library, plotted that as a graph. That is a simulated representation of what that looks like. I did have data for a much broader period, which I have unfortunately since misplaced. But that crisscross that Martin was talking about before, we had a really defined point in time where that crisscross occurred between Big Sur and Monterey. So that was really fun to do. That was the fun part. And as I said, I'm yet to see any profit. Now, while I was building this out, something I really heavily considered, and I will probably still pursue at some point, is the idea of taking the data that we're pulling out of the Jamf API, those smart group memberships, and then pushing those numbers into something like InfluxDB or any other kind of time series database, and then creating similar charts in something like Grafana so that we can then visualize the relevant data over time and then expand on that and change our time scales, etc. So similar things like major OS update rates and even the individual application patch uptake rates, etc. So the next problem that I needed to solve was a better understanding of our patch compliance status. And there's a couple of reasons why we might want to do that. The first one is that patching is a crucial part of the Essential 8. Now I know that John is talking about, it took me a second to remember who was talking about the Essential 8, and I think that's tomorrow, is that right? John's going to be talking about the Essential 8 a bit more tomorrow, but patching is a crucial part of the Essential 8. Our security team also have a mandate that we apply critical patches within a timely manner. And it's pretty much, at this point, I think, generally regarded as best practice. And we also run vulnerability scanning on all of our endpoints with central reporting. When those vulnerability tasks get generated, they get assigned to our resolver group in our ServiceNow platform when those vulnerabilities get detected, and I end up with something like 20,000 vulnerabilities every time there's a patch released. So obviously keeping that number down makes my anxiety less pronounced. So patching really helps us to understand that, and knowing the state of our fleet as it is right now really helps us to, obviously knowledge is power, but we can then target our comms out to individual users to say, hey, we noticed your machine's not up to date. Have you actually noticed that we're pushing comms to your machine to actually tell you to install the update or restart, those kinds of things. And it also helps us to identify some issues. Now again, the reason that I built my own here came back to a bit of frustration with Jamf, where honestly these patch management reports I don't love. They show me red and green and nothing in between. So it's either it is compliant or it's not, as far as our security team are concerned. But I want to know how far out of compliance that is. And so to do that, I am using the Jamf Pro API. Is this going to actually load? There we go. So I'm using the Jamf Pro API. That's the endpoint there that I'm pulling. And we can pull down a paginated list of all of our computer data as a JSON blob. And it looks a little something like this. And there's tons and tons and tons of data in there. If you've ever looked at the output of the Jamf API for a single computer record, it's huge. So once we've got a JSON blob, you can see things like there's the computer ID, there's the computer name, the last IP address. There's even some useful information in there that you can't easily get through the UI, like the initial entry date. You might be able to see kind of just below the middle there. So the first time that machine was seen by Jamf. And you'll also see near the bottom there, the extension attributes are a list of more JSON there as well. Now the nice thing about working with JSON and Python is that JSON blobs map pretty nicely to a list of dictionaries in Python. And so then I can expand things like the extension attributes and also group memberships into dictionary values for each computer. And then with those values all defined, we turn that into a pandas data frame. Now, while I was building the script out, I did also then dump this pandas data frame out into the widest spreadsheet I have ever seen of my entire Jamf inventory, which certainly was not easy to read, but definitely helped me to distill down those target columns that I really wanted to understand a bit more about. And when we talk about columns, you'll see in a couple of slides' time why that's actually pretty helpful. So then I'm breaking that big data frame down into some smaller major version data frames. And at the moment I'm doing that using smart groups, but I'm rattling around in my head with possibly a better way to do that, so that, because at the moment we're obviously right before presumably macOS 14 dropping, and I don't want to have to rewrite my whole code base when that drops. I'd like to just maybe tweak something at the top of the script to sort that out. Just for reference, yeah, and then we then throw every data frame at Plotly. For your reference, that is the Jamf API reference for returning paginated computer inventory records. Now, something that did bother me a teeny bit with this API endpoint that wasn't really well documented is the page size integer parameter there, which, as the name suggests, it limits the number of records per page of JSON. It has an undocumented upper limit of 2,000 records. So I can't pull my entire Jamf inventory of 4,500 devices down in a single API call. However, by simply iterating through a range, I can easily pull all of the pages down and put it into that one gigantic JSON blob. While I was preparing the presentation, I actually realized that I could make that range kind of enormous, like 0 to 10, and then break out of the for loop as soon as we get an error returned indicating that the requested page result didn't exist. So that means that I could reasonably grow to about 22,000 records before I need to expand that range. And I could, if I wanted to go down that path, actually just query the API to find out the total number of registered records, then divide by the page size, and then multiply by the number of spanners in a SID-Chrome toolset, and then just define the range that way, but that's another problem for another day. So when we throw the data frame at Plotly, we get something that looks like this. We see all of the individual revisions, and because I've filtered down to just the macOS Ventura machines in this data frame, we're looking at just the 13 dot something. Now, for whatever reason, and this has happened in 13.3 as well, I've seen recently, machines are reporting back with either 13.2 or 13.2.0, and we're seeing the same with 13.3. I do not know why it is inconsistent. It's not to do with processor architecture, it's just different. So I don't know why. So you'll also note here that in the top of, on the title of the slide here, that I've got that it is active and inactive devices, and that's because I can also run this report with a filter on the data frame of machines that have checked in within, say, the last 7 or 14 days or whatever. Because that last check-in data is already in the data frame, it's really just a case of filtering out anything that is beyond the threshold that you want to define. And something that's pretty helpful to really understand with the Plotly library that we're using to generate this data frame is that we can plot our chart based on and group these individual segments by any single column that's in the data frame that we throw at it. And once I discovered that, I ended up rebuilding the function that builds the donut graphs to take an argument for the group by column. So I then just need to pass in the name of the column that I want to group the charts by. It does need to be exactly the column name. So if we wanted to, for example, grab a chart based on the architecture of the machine, we can get something that looks a bit like that. And this chart actually outlines a little bit of an issue. It might be hard to see, but there's a little sliver of kind of a purpley blue at the very top. And you'll see in the legend in the top right that there's a null value. And that's actually an indication that we had a machine that froze during our automated device enrollment process, and it needs to be rebuilt, have the data purged from Jamf, and the machine re-enrolled. So something that would seem like it's purely statistical data, a graph breaking down the architecture of the fleet, actually helps us to identify problems with our environment and figure out how to address them. Another thing that I thought was kind of fun, but is actually not really of any practical use to anyone, is filtering or grouping by the individual devices that we have deployed in our fleet. As you can see, this is somewhat old data, but you can then kind of break down and see, well, these are the machines that we have out in the wild, and we can see that. Not much more. So with the Plotly library, as I said before, we can also then install the Kaleido library in the virtual environment where we are running the Python, and then save the chart out to a PNG file programmatically quite easily by calling the write image function on the graph object. And we define the file name, a width and a height. So if you really wanted to, you can export your charts in full 4K. Now in my case, I'm also using the Python to generate a folder structure to then store everything and keep everything organized. I have folders for each major macOS version. I have the folder for the different models of devices, and I also have a folder for the architecture. There's some other stuff in there that's specific to our NAB environment for our overseas development centers. And I've also got that 7-day filter in there as well. And I'm then also grouping those, as you can see, by year and month. To keep everything separated. And it gets, by using some F-string substitution, I'm also naming all of these charts so that I can run these reports as many times a day as I want, and I've got them all grouped together, and that comes into play when, for no real actual benefit, I should probably, yeah, that's the f-string substitution. So I've got the details there, the date and the time. And that really came into play when I wrote a separate script to turn the individual charts into an animated GIF. As I say, not really a whole lot of business purpose for doing this, but it was certainly a lot of fun. But also gives an opportunity to then kind of see if we're running these scripts at a regular interval, to then kind of see if there's maybe any kind of points in time where maybe it slows down or it speeds up, and potentially what those actually relate to, more than likely weekends. Anyway, the whole purpose of putting these graphs together was to then be able to provide some status reports to various stakeholders and teams to give them a bit of an understanding about the posture of our Mac environment and where we're standing in terms of patching. And honestly, throwing a bunch of PNGs at them, especially with my folder structure in place, was getting a bit tedious. Like I had to have to dig through, find all the right PNGs and attach them to an email or a Teams chat. But I also wanted to gather a little bit more information. So I created this incident dashboard specific for Macs in our ServiceNow platform, so that I could see Mac-specific incidents, where they were coming from, and if they were related to, at the time that I created this dashboard, we were getting a lot of machines that were rebooting and sitting at the EFI passcode screen, and we don't provide end users with our EFI passcode, and so we were getting a lot of tickets related to that. We don't have those tickets happening so much anymore, so I could probably do with rejigging this dashboard. But obviously, for a complete report to management or whoever's requesting it, ideally this information included would be helpful, but I don't have access to our ServiceNow API. So I built out the browser automation function with the Selenium automation that I mentioned before to go to the URL of this dashboard, sign into ServiceNow using the credentials that I pass when I authenticate to the Jamf Pro API, resize the window to 1920 by 1080, and take a screenshot of the content as a PNG file. And then I take the PNGs that I've created throughout the whole process of pulling the reports, use the Python PPTX library and place them all in a specified order into a PowerPoint slide deck that I can then quickly just shoot that slide deck through to the relevant stakeholders. That's pretty much it for patch compliance. It's honestly the biggest part of the reporting journey that I've built out, and definitely the most complete, though there is a ton of stuff that I definitely need to fix at some point in that code base. Next up, and slightly off topic because it's not using Jamf data, but performance metrics. It was certainly part of my reporting journey and produced some really interesting results and some business relevant results as well. There's a couple of reasons we might want to do this. Obviously, validating new hardware. Apple have released their Apple Silicon devices. I'm not sure if you've heard, been around for a little while now. But we can make some data-driven purchasing, hardware purchasing decisions, decide whether we want M1s, M2s, whether we need Pros, whether we need Airs, those kinds of things. And this whole process came about, I was asked about really quantifying the performance of different machines so that we could then justify the extra cost to start purchasing the M1 Pro machines. And it was only really mentioned in passing, but I decided that I wanted to do it anyway. And it was also really supposed to be in the context of justifying Macs versus Windows on a performance basis. And while I never got around to actually gathering any data or quantifying that for the Windows platform, it was certainly a fun project with some interesting learnings, which you'll see in a second. Now, without a really good API to gather this information, and it's not coming from Jamf, I had to create the data set manually. And this is the data set that I ended up creating. It's just a spreadsheet where each row is a different model of Mac, and each column is the time in seconds of a run of the Xcode benchmark project, which I pulled from Git on each machine and ran 6 times. And then the last column is a calculated average of those 6 tests. And of course, I'm then loading this spreadsheet into a data frame. If you've never seen a data frame before, now you have. That's basically what it is. When I first ran the, I obviously throw the data frame at Plotly and I get this graph where lower is better. And I had this really weird result where I got a graph that looked something like this. I've obfuscated some data for dramatic effect a little later on. I was really confused about why this 16-inch Intel Core 6-core machine was running worse than a 13-inch quad-core, let alone a 15-inch 6-core as well. I'm like, well, it's the same processor and theoretically a better thermal design. So I'm like, well, what's going on? I pinned the fans at 100% and it got a little bit better. About on par with the 13-inch quad-core, which was still very confusing for me, but really not better enough to really bring it back into line with the 15-inch. But it turns out that as part of a project proof of concept, I was running Microsoft Defender on that machine, and that was blowing out my build times. So a fresh install with no Defender brought the performance back down to roughly in line with the 15-inch. So I actually have quantitative data that Microsoft Defender does affect the performance of a device. As you can see from the graphs here, a 13-inch M1 8-core performs about twice as well as the best Intel device here. An M1 Pro 8-core shaves about 25 to 30 seconds off that build time. An M2 Pro 10-core shaves about the same off that build time. And for just giggles, I benchmarked this machine, which is an M2 Max, and it brought the build times down to sub 80 seconds pretty consistently. That said, this is not a fair apples to apples comparison, pun intended, because my personal machine obviously doesn't have any of the NAB management overhead that would be added to there. So back to something a little bit more relevant, we've got device and refresh eligibility. Now in our environment, despite the unrelenting rallying from both us and from Apple about total economic impact, we still have a strict eligibility criteria in place for our users to qualify for the Mac platform. Our users need to demonstrate a clear technical justification for the Mac platform, such as a need to use any of the Mac OS exclusive tooling or the tooling that is considered Mac OS exclusive in the NAB environment. And my home alarm just went off. In some cases, users who have previously been issued a Mac may no longer actually qualified if they no longer use any of those Mac exclusive tools. Or what we're finding with increasing frequency, they never made use of the tools that they claimed they needed when they requested a Mac. And also with our aging fleet, a lot of our devices are now 4, 5, 6 years old. Some of these machines a lot of these machines are coming up for refresh, and we also need to target our refresh comms specifically to users that meet the eligibility criteria and continue to meet that eligibility criteria, and also the devices that are approaching or have passed that scheduled retirement date. Now, getting the scheduled retirement date data was a little bit challenging. However, our asset management team produce a daily report containing the scheduled retirement date of all of the machines in our fleet, both Windows and Mac. And I managed to get myself onto the distribution list for that daily report. So I import that Excel spreadsheet into a data frame. It's, again, a very wide Excel spreadsheet. And using pretty much the same process as our patch compliance reporting, I'm pulling the Jamf inventory down for the full macOS fleet into another data frame, but I do also break out a couple of additional things like some EAs into specific data points, and also the installed applications and the versions of those installed applications into columns on the data frame as well. The reason I do this, so for example, if Xcode is installed on a machine, but it's version 12.5, when we in the macOS engineering team happen to know that all of our mobile developers who are actually doing work on anything that's being released out into the wild have been using Xcode 13 for the last year, we can make a pretty reasonable assumption that this user isn't actively making use of Xcode and probably doesn't need it. There's some other applications where if they're not up to date, we can assume they're probably not being used. And we've also got an EA that tells us the last time one of our qualifying tools was used. Now, one of the to-dos that I've got for this project is to actually start looking at the application usage stats that are stored in the Jamf inventory data to see if the applications are in fact being actively used. Because just because the correct version of the app is installed doesn't automatically mean that it's being actively used, but that's another story and it's a much more complex problem to solve. But anyway, we've got our Jamf data frame, we've got our asset report data frame, and then I smash them together, merge them based on the serial number, which is conveniently based in both data sources, and the code looks a little something like that. I then do a little bit of calculation on that data frame, like calculating the number of days past the retirement date as of today's date. I check the installed app versions are greater than a predefined value. The last used EA I mentioned before is within the last 30 days from today's date. And also I check that the last check-in is within the last 30 days as well, and drop anything that doesn't meet the criteria. We tidy up the data frame and drop some unneeded columns as well. And we output something that looks a little bit something like this. I have cropped out of the screenshot deliberately here things like the computer name, the person who's using it, their role, etc. But the important data here is things like our retirement date, the days past retirement, the eligibility criteria that they used, and a Boolean value of whether it's due for refresh. And that's really calculated on whether it is past its retirement date or within 30 days of that retirement date. Once we've got it into Excel, we can start doing some other things like filtering based on if we were not dropping stuff that's false in this due for refresh, we could then start filtering those results and target comms only to users who meet the current eligibility criteria and are due for refresh. Or we can look at users who are not eligible for a Mac and are due for a device refresh and invite them to come in to pick up their new Windows device. And then the real weaponization of this data, which we haven't actively done at this point, is to look at the devices that are not due for refresh and don't meet our eligibility criteria, and then start looking at reclaiming those devices for use with eligible users. I don't know that we'll ever get to that point. I think prying Macs out of people's cold dead hands is probably not a great way to get our development communities on board with the Mac program, but we shall see. Now, a byproduct of this eligibility reporting was that I was able to produce a list of every app installed on every Mac across the entire fleet. I'm already iterating through the JSON data to check for macOS exclusive tooling, and I'm looking at every app on the Mac anyway. In order to do that, at least I'm seeing all of the apps that the inventory is gathering. Now, this is pretty useful. We are in a regulated environment. We are a bank. We have a pretty restrictive information risk policy that explicitly prohibits users from installing and using unsanctioned applications on their endpoints. I think that's not uncommon for most businesses, but we enforce it pretty heavily. And something that John will no doubt talk about tomorrow is application control in regards to the Essential 8. Someone in our security team has obviously recently read the Essential 8, and application control is becoming a major focus for us at the moment. Now, gathering this data was both a blessing and a curse. This is all the information, not all the information. This is just 30 rows of about 4,000 rows of data that I pulled out of Jamf. So after pulling this CSV file, or pulling this data into a data frame, I've got the application name, the versions and their installed locations. I turn it into a data frame, dump it out into a CSV file, and then comes the fun part, quantifying what everything is, and then whether or not it's a sanctioned app or if it is in fact in breach of our information risk policy. Where the apps are not sanctioned, I have then created restricted software policies for them, and when I first ran this report, I spent the next week creating over 300 restricted software policies, which I did do manually because I was a bit overcautious about using the Jamf API to create them, but I think next time I would actually use the Jamf API to do it, given my time again. We're currently also in the middle of a project to roll out Santa. And the data that I've gathered through this process is really a great starting point for our Santa project to make some decisions on what we can allow and what we can deny. And this really leads me neatly into restricted software violations. Now, for all of the same reasons that we spoke about before, but I'll add in my personal opinion here that if we don't report on behavior and call it out, we're never going to correct that behavior. So I've decided to build a report based on the policy violations, and this was a fair bit harder to do because the Jamf API does not provide this data. You cannot pull this data out of the Jamf API. What you can do, however, is scrape the Jamf server log. I have to manually download the Jamf server log from the Jamf UI and place it into the folder with the script. And when we scrape the log, we're looking for an entry blacklist notification because Jamf hasn't been updated to be more politically correct yet. And that entry looks a little bit like this in the logs. So we've got information like the date and the exact time that that occurred. We've got the username of the person who ran that process. We've got the computer name that ran that process, the log header, as I mentioned before, and the process name. Again, I've redacted some information here for reasons. So once again, I am pulling the data, and I'm pulling the full Jamf Pro inventory as well, mashing all of this together against the computer name that we saw in the previous the Jamf Pro server log, and then matching all of that up so that we can see the users, the full name, the email address, the role, the computer, and I've also got the location in there, because sometimes it's kind of interesting for me to look at this data and go, are they using this application because of some kind of cultural reason? Is it a specific team, or is it maybe just localized to one part of the world? This report is the very definition of weaponizing Jamf data, because its only purpose is to name, shame, and report to management the users who are doing the wrong thing. This will no doubt be a controversial view, and some of you are thinking, we'll just hire good people and get out of their way. And some of you have expressed this sentiment to me in other forums in the past. However, as we've already mentioned, application control is part of the Essential 8. We are also, I'm wrapping, yeah. We're also obligated to report vulnerabilities detected back to the industry regulator. I am being told that I need to wrap pretty quickly. Sublime Text is also licensed, and that could be a legal problem if we are not appropriately licensed. I did also have some stuff in here. I did a Jamf inventory preload, which that was definitely a misadventure. It's a three-way pandas merge with data from Apple Business Manager, our ServiceNow Assets Management Report, and Apple Care for Business. We don't have a GSX set up, so I was able to mash these three data sources together and then push this data up into our Jamf inventory preload. I really actually wanted a way to figure out what devices were in our overseas development centers. And the best way I could think of to do that was based on the vendor that they had been purchased from, which is data that we can pull from Apple Business Manager in the CSV file, which is quite nice. Jamf inventory preload records are here. You can see there's quite a lot of information you can put in here. There is a frustrating error with this at the moment. I don't think it's actually on here. The documentation has a string defined for the expected lifetime, but it expects an integer in the database schema. So it'll accept a string in the API, but the database schema is expecting an integer. What's next? I am planning to share this to GitHub at some point for anyone who is interested in tooling around this stuff. There is a fair bit that I need to do before I can do that. At some point, I'm going to do 100 days of Swift UI so that I can then potentially achieve some of the same or similar results without Python. As I mentioned before, I'd love to take the data that we're producing and pipe the relevant data into InfluxDB and use Grafana to visualize over time. Or maybe I should just use Splunk. So some of the to-dos before I'm ready to share on GitHub, I need to sanitize everything, remove some of the NAB-specific stuff out of there. I do need to revisit some of the abstraction in the scripts. I built a lot of this to just get the job done, and the code quality definitely suffered for it. There's hard-coded variables, hard-coded values that should be variables, etc. The way I look up major versions I want to sort out. As I said before, when macOS 14 beta drops in a couple of months, it's going to break. That's probably the core of what I want to change before I share. There's other stuff I'd like to do, async IO I mentioned before, and also try and consolidate this possibly into a single kind of tool, but that might actually be more likely useful for something like Swift UI. Resources. The Jamf API documentation was a great help. This is way better than it used to be when it was the Swagger documentation. That was garbage. Sorry, Jamps. The language-specific examples, instead of just the curl commands, has made it a lot easier for me to wrap my head around some of this stuff. That's a link to the 100 Days of Code Python Udemy course that I did. It is a paid course. It is listed at $59.95, but it's almost always on sale. But if you have a Udemy business subscription, conveniently, you can probably do it for $0. You don't have to do that one if you're already comfortable with Python, Pandas, and Plotly. And lastly, the Plotly website was really helpful when I was building out those donut graphs. If you want to get in touch, some links. There's my GitHub, so when I get around to it, finishing up some of those to-dos, I'll be making scripts available on there. There's some of my older stuff on there as well. I'm sometimes in the Mac admin Slack. If you're not already on there, get on it. And the QR code takes you to my link tree. There's links to my YouTube, my Etsy store. I just launched a new website this morning. And Twitter, Instagram, Facebook's all on there as well. And that's it. Thank you. Thank you.